All right, let's take a look at solving linear equations in one variable. Now we got a big giant title up here, so let's go through and make sure we know what all the words mean in our title. We've already covered a few of these, like we know an equation is something with an equal sign, and we know for solving we're looking for a solution. Now what do we mean by in one variable? This can be confusing sometimes depending on how you look at an equation. Like if I had 2x plus 3 equals 5x plus 4. How many variables would you say we have in this equation? Well, it'd be very easy to say you got 2 because you got some over there and you got some over here. However, when we're talking about how many variables are in an equation, we're talking about how many different letters there are. The only letter in this equation is the letter x, so we would say this is an equation in one variable because there's only one letter. If I were to add something like that, now this would be an equation in two variables because we have two different letters. We have x's and y's. All right, so the last thing we need up here then is, what does linear mean? Well, we said that an equation is anything with an equal sign. So that's very, very broad. So what we need to do is narrow down what types of equations that we're talking about. And the word linear here is telling us what type of equation it is. Now, if I were to ask you what does linear mean, almost all of you would say, oh, it means a line. Well, it doesn't mean it's a line. It's related to a line, and we'll see a little bit later in our future how it is related to a line. But for today, all we want to associate with the word linear is the highest power is 1. Okay, that's it. I'm just going to swing this down here a little bit. Give me a little bit more room. The highest power is 1, which means you're not going to see an equation that has anything like x squared, y cubed, or anything like that. So now we know what type of equations we're going to deal with. We're going to have only one letter in them, and that letter at most is going to be raised to the first power. Now here's the great news about math that I think a lot of people overlook. As soon as you can say what type of equation it is, there's a step-by-step process, which I've already written down over here, that will help you solve every single one of those types of equations. So let's just kind of go through and look at a few of these. So our directions for this lecture is just going to be solve. So let's start out with a nice, easy equation. Now, this is where it's going to get a little bit tricky for what you guys are doing in your homework, because I'm well aware that all of you can solve this. Everybody already knows the answer is 1. But I'm going to try to have you guys do a lot of extra steps here to kind of train yourself on how to approach math and how to approach solving equations. So the very first thing you need to do when you're solving any type of equation is say, what type of equation is that? Well, this is an equation because that is an equal sign. It's a linear equation because all of our variables are raised to the first power. So we can say that this thing is linear. Now, by saying that it's linear, we can follow these steps over here. And for a while, for every single problem you solve, you should read through every single step. It's going to help you memorize it and help you get an idea of how the process works. So let's try reading through this to make sure that we understand what the steps mean. Step 1 says clear grouping symbols. So that means any parentheses, square brackets, curly brackets, whatever. Well, we don't have any here, so step 1's already done for us. Step 2 says clear fractions or decimals. Again, I haven't showed you how to do that yet, but we don't have any fractions or decimals anyway, so that step is already done. All right, step 3 and 4 is going to have us moving stuff around. So the first thing says move all your variables to one side. So what do I mean by that? Well, let's take a look at this. The equal sign is the separator from the left side compared to the right side. Now, what do I mean move all your variables to one side? Well, on the left-hand side, we have 2 terms. On the right-hand side, we only have 1 term. So there's a total of 3 terms in this equation. Only 1 term has the variable with it. So every term with an x is on the left-hand side. So technically here, step 3 is also already done for us because it's a really easy equation. Step 4 says move everything else to the other side. So since we have all the terms that have x's on the left, any term that does not have an x needs to go away. Now to do this, most textbooks are introduced what they call the properties of equality. The addition property of equality, multiplication property of equality, and some even expand it to the subtraction and division property of equality. But you can sum up all these math-sounding things into one simple rule, kind of our golden rule when we're solving equations. Whatever you do to one side of an equation, you have to do the exact same thing to the other side, because it's got to be equal, right? It's got to stay the same. So let's see here. If I have a plus 2 on this side, to get rid of a 2, I would have to subtract the 2. And of course, whatever I do to one side, I do to the other. Now I'm writing it underneath because I think this is the way most of y'all were shown this. So basically what we're doing is we're just adding stuff together on this side. So all I have on this side is an x equals, and 3 plus a negative 2 would be a 1. Excuse me. Our last step says, divide both sides by whatever's in front of my variable. Now in this case, there's a 1 in front of the x. If I divided both sides by that, we'd have the same answer. So there you go. There's our answer. Now remember, if we wanted to check it, all we'd have to do is plug this back in and see if it gives us a true statement. All right, let's try several more here. Let's go like 2x plus 3 is equal to, I don't know, 7. All right, now remember, before you do anything, before you start solving, moving stuff around, dividing, or whatever, we have to always classify it, because we can't use these steps unless this is a linear equation. It's an equation because it has an equal sign. It's linear because all of our variables are raised to the first power. So those steps over there on the right should work for us. Step 1, clear grouping symbols. We don't have any, so that's already done for us. Step 2, clear fractions or decimals. Again, no fractions or decimals, so we're done with that. Step 3, move all your variables to one side. Again, here we have 3 terms in our equation. Only one of the terms has the variable with it, so all the x's, or all the terms with x's, are already on the left. Move everything else to the other side. Well, this 3 is over here with x's, so we need to get rid of it. So to get rid of a positive 3, I would subtract 3. And of course, whatever we do to one side, we have to do to the other. Then we combine our like terms. On the left-hand side, all we have is 2x. 7 plus a negative 3 would be a 4. All right, so we got every term that has an x on one side, every term that doesn't have an x on the other side. Last step says divide both sides by whatever's in front of my variable. I have a 2 in front of this x, so I'm going to divide both sides by 2. So we get x is equal to 2. All right, step by step, every single time. So let's go back this way so we got a little bit more room. We can get rid of our title. You remember our directions are going to be the same for the entire lecture. It's just going to be solved. Let's say we got 4x minus 5 equals 2x plus 8. All right, again, remember, before you should jump out there and start doing anything here, you want to say what this thing is. Well, it's an equation because it has an equal sign. It's linear because our variables are only raised to the first power. So again, I'm going to just remind myself that this is a linear equation. Step 1, clear grouping symbols. I don't have any of those. Step 2, clear fractions or decimals. I don't have any of those. Step 3, move all your variables to one side. Now in this case, you can see I have a term that has x's on the left and a term that has x's on the right. So we don't have all of our x's on one side. So you need to move them to one side or the other. Does not matter which side you move them to. Most students tend to prefer moving them to the left, which means getting rid of them on the right. So if I don't want any x's on the right, I'm going to have to take away 2 x's from that side. And whatever we do to one side, we got to do to the other. All right, if we combine our like terms here, that gives me 2x minus 5 is equal to 8. Now that we have every term with an x on the left, we need to move everything that doesn't have an x to the right. This negative 5 doesn't have an x, so we got to get rid of it. So to get rid of a negative, we're going to add 5, and whatever we do to one side, we have to do to the other. So we get 2x is equal to 13. Last step, divide both sides by whatever's in front of my variable. There's a 2 in front of that x, so we divide both sides by 2, and we get x is equal to 13 halves. All right, so our answer in this case ended up being a fraction, and they will be. Not all your answers are going to be nice, pretty numbers. Now this is an improper fraction, which is a crappy name because it's improper kind of makes it sound like there's something wrong with it. There's nothing wrong with an improper fraction at all. In fact, I prefer you to leave it like this instead of changing it to a mixed number. However, do make sure that this fraction is reduced, and that won't reduce at all. So we're going to leave our answer just like that, 13 halves. All right, let's take a look at a couple more examples. All right, let's see if I have... Okay, a little bit more complicated here. Again, our directions, of course, are just solved. So before we start doing any steps to solve something, we got to say what type of equation is it so we know what steps to use. Here it's an equation, of course, because it has an equal sign. All the variables appear to be raised to the first power, so I'm going to call this a linear equation. Now, step one says clear grouping symbols. Excuse me. We do actually have grouping symbols here, and anytime you're ever going to get rid of grouping symbols, you always distribute. So let's see, 3 times 2x gives me 6x, 3 times -4 is -12. All right, next step says clear fractions or decimals. We don't have any of those yet. Move all your variables to one side. So again, I have x's on the left and the right. Again, I'm going to move them to the left because most of you tend to do that. So I need to subtract 5x from both sides. That'll get rid of all the x's on the right. So that gives me x minus 12 is equal to -2. Now that I got all my x's on the left, I need to move every term that doesn't have an x to the right. So I need to add 12 to both sides. So we get x is equal to 10. Last step says divide both sides by whatever's in front of your variable. Since there's a 1 there, we're already done. Now remember, if you wanted to check this, all you'd have to do is plug it back into the original equation and see if it gives you a true statement. All right, let's take a look at maybe one more here. Let's make it a little bit harder. Hardest one yet. Here's what we're going to do. Let's see if you're kind of getting the idea of what's going on here. First thing you always want to do is classify it. This is a linear equation. So I'm going to go ahead and call this thing linear. Why don't you go ahead and hit pause on the video and see how well you can make it through this one, because this is by far the hardest one yet. So pause and then come on back when you think you're done. All right, you're back. So let's give this a shot. Let me give me a little bit more room here. All right, since we decided it was a linear equation, our steps over here on the right should help us solve it. So step one, clear grouping symbols. We always use our distributive property for that, so I'm going to distribute the 4 here. All right, so this gives me 8x minus 12 plus 3x is equal to 5x plus 7. Step 2 says clear fractions or decimals. Now we don't have any of those, so that step's already done for us. Step 3 says move all your variables to one side. Now, here's where a lot of mistakes are made. So I'm getting ready to make a mistake, so don't copy this down. I'm going to show you something that happens a lot with students. A lot of times you say, okay, I want to move all my x's over here. And you say, okay, I'm going to subtract 5x to get rid of them. You say, oh, well, I got x's right there and I have x's right there. Well, that's wrong, because think about it. On this side, all you subtracted was 5x's. But on this side, you actually subtracted 10x's, which means you broke our golden rule. Remember, whatever we do to one side, we got to do the exact same thing to the other. Now, to keep this from happening, I'm going to give you one more air quote step over here. Now, it's not written in as a step because it's not part of the solving method, but it will help you from making mistakes from time to time. Before you start moving anything around, always simplify each side before moving things around. All right, if you always simplify each side first, then you won't run into the kind of mistake that we just made here. Now remember, simplify just means do everything that you can do. So looking at the left-hand side, we have some like terms. So 8x's and 3x's give me 11x's minus 12, 5x plus 7. All right, now when we go to move our x's, let's say we did the same thing, try to move the 5x's over here. Notice we don't have that visual problem we had last time. We only have one place to actually line that up at. So let's see, it's 6x minus 12 is equal to 7. Got all our x's to the left, let's move all the numbers to the right. So I'm going to add 12 to both sides. So we have 6x is equal to 19. Last step, divide both sides by whatever's in front of our variable. So we get x is equal to 19/6. Now again, we ended up with an improper fraction. Remember, that's fine. Generally, you don't want to change this to a mixed number. Leave it just like that. Just make sure that it is simplified. So as you can see in this case, we can't simplify that fraction. So that's it for this problem. All right, I think that's going to end us up for part 1. Part 2, we're going to take a look at all the other things that can happen when we're solving linear equations.